Okay, so connecting with the hypothesis testing for variances. So the today lecture topic is chi-square test. In this lecture, as I already discussed in my previous lecture related to the chi-square test statistic, in this lecture I am going to discuss some general practical example that how you will handle a specific data, how you will calculate the chi-square test, and then after that how you will interpret the critical region. Should you need to accept, should you not need to accept. So before going to that, I just want to discuss a very simple example. So you can see this is a very simple example. A commercial freezer must hold the selected temperature with little variation. Specification call for a standard deviation of no more than 4 degree. So this will be no more than 4 degree. This is the standard deviation, the variation. Variation in what? The temperature. That it will not more than 4 degree variation will be occur. Our variance of 16 degrees. So standard deviation is 4 degree. So normally we write standard deviation as 4 degree. So the variance, because it is the square, it will be 16. So taking the square root of this, it will be 4. So if in some specific example, if they give you standard deviation, so you can easily calculate variance. A sample of 16. So this is the claim of the company that we hold the selected temperature, our freezer hold the selected temperature with little variation, and they say that this variation is not more than 4 degree. So an inspector came to their company and they took a sample of 16 freezer and they tested. So what is N? N is 16. Okay, a sample of variance, and from those 16 samples they calculated that the variance is, so we denote this is the sample variance, and that is the population. This is the population and this is the sample variance. Sample variance is 24. Test to see whether the standard deviation specification is exceed. Use alpha is 0.05%. So now, is the claim of this company is valid? Should we need to accept, should the inspector who is inspecting the quality of the freezer, that is this is not more than 4 degree, or is it equal to 4 degree? Is they fulfill this variation which they claim for or not? So while solving this example, first of all we need to construct null and alternative hypothesis. So the chi-square test statistic, then the chi-square table to find the critical value. I will show you that how we will find this. N is 16, so degree of freedom is this one, 15. Degree of freedom is this one, and chi-square statistic. So you people know this chi-square statistic is summation x minus x bar whole square divided by the variance. So you people know that s square is equal to summation x minus x bar whole square. This is the variance formula. You can also write n minus 1. S square is equal to summation x minus x bar whole square. So this square deviation is equal to n minus 1 s square. So n minus 1 is 16 minus 1, and s square, they already give the sample standard deviation, this one, which is 24. So 24 divided by the population standard deviation is 16. So 22.5. Now, in order to check that their claim is correct, should we need to accept the company claim or should we not to accept the company claim? So because this is the right tail test, they say no more than. Okay, so this is the right tail test. Right tail test, it will be start from 0, and for right tail test it will be n minus 1, and this is 0.05, and n is 16, so degree of freedom is 15. So now we will find out 0.05 in the chi-square table for the degree of freedom 15. So now I am just going to the chi-square table in order to find out this value 0.05, and the degree of freedom is 15. So this is our chi-square table. You can see we are looking for 0.05. So this column is 0.05, this one, and we looking for 15. So this is the degree of freedom. The first column is degree of freedom. This is 15, and we looking for this. So this is 24.996. Okay, so we will write this 24.996. So that is why you can see that this is 24.996. This is our accepted region. Accepted region 1 minus alpha, and this is our rejected region. Okay, so you can see that the calculated value, it will be mean 22 will be lying because this point is 24.99. So 22 22.5, the calculated value, this point lies in the accepted region. So we will accept there is not significant evidence at level of significance this, then the standard deviation specification is exceeded. So it's not exceeded. So it lying in the accepted region. So therefore our null hypothesis will be accepted. Okay. And so null hypothesis was what? That it will be less than or equal to this, or if you want to write this, it will be null hypothesis will be, if you want to write the standard deviation, should not more than 4. Okay. Alternative will be the opposite of this. Okay. It will be more than 4, because no more than 4. This is the claim. They claim that specification call for a standard deviation of no more than 4 degree of freedom. No more than standard deviation of no more than, or if you want to use the variance, no more than 16 degree. So no more than 16 degrees. So no more than mean we can write this, it will be 4 or less than 4. And the opposite of this will be greater than 4. So from this experiment we see that what they claim that our freezer holds the selected interval with little variation, specific call for a standard deviation of no more than 4. So they are right. We will give them a green signal. Okay, there is another example. The variability in the tensile strength of a type of steel wire must be controlled carefully. A sample of the wire is subject to test and it's found that sample variance is 31.5. So this is sample variance. The sample size was 16. So they actually from the wire they took a sample of 16. The sample variance is 31.5. Test the hypothesis that the population variance is 25 against the alternative. So test the population variance is 25. So null hypothesis is 25. Against the alternative, that variance is greater than 25. So greater than, what kind of sign we will use? If they not give us this greater than, then we will write alternative not equal to, it will be a two-tailed test. But they clearly mention that the alternative, that the variance is greater than, so we write greater than 25. They already mentioned that use a level of significance 5%. So this is the right-tailed test. The level of significance is already mentioned. Test statistic, because this is related to the variance data. There is no mean of the data. So we will conduct a hypothesis test about a variance, and we will use a chi-square because there is only one type of data. So chi-square is equal to summation x minus x bar whole square by this one. So you people know that the variance formula for sample is summation x minus x bar whole square divided by n minus 1. So n minus 1 into a square. So the square deviation, this will be square. Okay, this is square. Summation x minus x bar whole square is equal to n minus 1 s square. So we can also utilize this side, because this thing is equal to the square deviation. So at this portion we can put n minus 1 s square divided by standard deviation variance. So n minus 1, because n is 16, so 16 minus 1 is 15, and s square, they already give you s square. This is sample variance. We denote this with s square, okay, which is 31.5. And population, so they already give you the population variance. This is population variance. They already mentioned to you population variance. So 25. So this is basically the calculated value of chi-square. This is the calculated value of chi-square, 18.9. Now we need to construct a critical region. So from this alternative hypothesis, we need to identify that our critical region is left tail, right tail, or two tail. So basically this is the right tail. So right tail, because chi-square alpha n minus 1. Alpha is, they already mentioned to you, this is 5%. So 0.05. N is 16. 16 minus 1 is 15. So now we will go to the table. So in the previous slide, I already checked, I have already calculated this. So in the table, in the 0.05 column, and against the degree of freedom of 15, you will find out 24.996. So this threshold is 24.996, which split the accepted region and rejected region. So as the calculated value, because this is start from 0, calculated value will be lying over this. This is 18.9, near to 19. So the calculated value, this one, is lying in the accepted region. So as the calculated value is lying in the accepted, so we will accept H naught. We will accept that the population variance is 25. That the population variance is 25. And the other claim, the alternative claim that they greater than 25 is totally wrong. So there is no such strong evidence for the alternative hypothesis. So that is why we will reject our alternative hypothesis and we will accept our null hypothesis. Okay. There is another example in order to further clarify that how you will use left tail test, right tail test and two tail test in the chi-square statistic. So I hope that from this example you will also understand how to conduct a two tail test. So given the chi-square xi are normally distributed, so xi is a variable normally distributed, and given the sample value, sample mean 42, sample standard deviation, so we can also denote this with the sample standard deviation. This is sample mean, this is x sample mean, so this is x bar, and sample size, this is n. Test the hypothesis that it is equal to 8. So h naught is standard deviation is equal to 8. As I already mentioned this one. And what will be the alternative of this? Alternative will be it's not equal to 8. So basically this is a two tail test now. We need to construct a two tail test. Level of significance, if they mention, then okay. Otherwise you can take 5%. So we already took 5%. Test statistic. As you know, test statistic formulation is this one. So as you know that the sample variance is summation x minus x bar whole square divided by n minus 1. So taking this on this side, n minus 1 s square sum is equal to summation x minus x bar whole square. So just like the square deviation is n minus 1 s square, so n is 20, 20 minus 1 is 19 and s square. So sample standard deviation is 5. So what will be s square? S square will be the square of this, so it will be 25. So multiplying by 25, and the population they already give to you. This is the standard deviation. So what will be the square of the population? It will be 64 because this is 8. So 8 are 64. So this is 64, and we calculated this calculated value for chi-square test. Now we need to construct a chi-square table region, critical region, because now we not know that is it in the upper bound, is it in the lower bound. Is it in the upper tail or is it in the lower tail? So what we will do? We will divide this level of significance into portion. So as you know, alpha is 0.05. We will divide this because we are not sure. So that is why 50% of the error will be on the upper side and 50% of the error will be on the lower side. So 0.025% will be on this side and 0.25% will be on this side. Now we need to calculate these thresholds. So as you know, as I already mentioned in my earlier lecture, for two tail test, this will be the distribution chi-square alpha by 2 n minus 1. So alpha by 2 means 0.025 and n is 20. So 20 minus 1, 19. So first I am going to the table, and this one is 1 minus alpha by 2. So alpha by 2 is 0.05 and 1 minus 0.05 will be 0.975 and this will be 19. So at first instant, we will be looking for 0.97 alpha value for chi-square, and we will be looking for the degree of freedom 19. What will be the threshold for this? And what will be the for 0.025 against 19? So I am just going to the table in order to show you that how you will calculate these values from the chi-square table. So this is my chi-square table. One is 0.975 and we looking for the 19. So you can see this is degree of freedom 19 and this is 0.975. So this is 8.907. 8.907. So you note this, and the other one is 0.025. This is 0.025 against the degree of freedom 19. So you can see this is 32.852. So these are upper and lower threshold from the chi-square table. We will write these value in the diagram. Okay. So you can see for this we find out these value 8.907 and for 0.025 against the degree of freedom 19 is 32.825. Now this is our rejected region and this is our accepted region. So basically this is the accepted region and this one is the rejected region and this one is also the rejected region. So 7.42 because this is start from 0 and this is the threshold is 8.90 and this one is 32.85. So the calculated value lying at this point. So your calculating value is lying in the rejected region because except in region start from 8.90. So your calculated value lying in the rejected region in the lower tail. So that is why we will reject. The standard deviation is not equal to 8, but it is less than 8. You can see it is less than 8 because it's lying in the lower tail. So that is why we will reject H0. So I hope that you understand from this example. There is a very short assignment. You also need to try this at your home. You need to solve this because in this example, a sample of 9 parts produced. So N is equal to 9. N is 9 produced by a certain production process are measured. So X will be 5, 7, 2, 4, 8, 9, 8, 6 and 5. So these are 9 different processes, products. Test the hypothesis that the process, so null and alternative process has a variance equal to, so variance H0, variance is equal to 4 inches, alternative will be not equal to 4 inches. So it's a two-tailed test, okay? You need to use a two-tailed test and level of significance is 0.05. So you need to construct a two-tailed test. Okay, two-tailed test will be at this one minus this. Okay, degree of freedom will be n minus 1. So n is 9 minus 1, it will be 8, and this side will be because you will divide this alpha by 2 and this is alpha by 2. And this one will be alpha by 2, 8. Okay. And how you will calculate this? Because from this you can calculate chi square is equal to summation x minus x bar whole square divided by this thing. So you can easily calculate x bar, which is equal to summation x by n. You can easily calculate minus x bar and then square, and then when you add it, it will be x minus x bar whole square. So you solve this question and from the table use the chi-square table to find out the values. That is the claim of this question, that the variance of population is equal to 4 inches or not equal to 4 inches. Is it lying in the lower tail or is it lying in the upper tail? Thank you.